This chapter is the hinge of the entire course. It's where storage connects to backup and recovery. And it hangs on one switch, archive log mode. Here's why it matters so much. Almost every serious recovery scenario you'll ever be asked about depends on the database running in archive log mode. Hot backups, point-in-time recovery, surviving a media failure without data loss, all of it. So interviewers test this concept constantly, because it's the gateway to everything in Phase 4. We'll build up redo, then checkpoints, then the big switch, and by the end you'll understand exactly why we run in archive log mode is the only acceptable answer for a production database. Let's start with redo. Building on Chapter 9. Redo records how to reapply a change. Every committed transaction gets written to the online redo log files by LGWR, the log writer from Chapter 4, at the exact moment you commit. And that's what makes a commit durable. Even if the instance crashes 1 second after your commit returns, the change is already safely on disk in the redo log, and it can be replayed. That's the durability guarantee stated in full. And remember the mechanics from Chapter 7. The online redo logs cycle through groups, performing a log switch each time a group fills up and moving to the next. Keep that cycling image front of mind because in a few slides it's the overwrite step in that cycle that archiving completely changes. Next, checkpoints. A checkpoint is a moment in time when Oracle guarantees that all the dirty data blocks up to a certain point have been written from the buffer cache out to the data files by DBWN. And the CKPT process, Chapter 4 again, records that position in the control file. Why does this matter? Because it bounds recovery. Without checkpoints, recovering after a crash might mean replaying an enormous amount of redo, going back who knows how far. With them, recovery only has to start from the last checkpoint. So checkpoints make a deliberate trade. A little steady, ongoing disk writing in exchange for dramatically faster recovery when you need it. That's almost always a trade worth making, and it's why Oracle takes checkpoints continuously in the background. Now the big one, the concept to absolutely nail. When a redo log group fills and the cycle eventually comes back around to reuse it, what happens to its old contents? That depends entirely on one setting. In no archive log mode, the old contents are simply overwritten and lost forever. The consequence is stark. You can only recover up to your last cold backup, and any changes made after it are gone. In archive log mode, before a filled redo group is overwritten, the archiver process, ARCHIN, copies it to an archive location, often the fast recovery area. Those archived logs form an unbroken, complete history of every change ever made. So the whole difference is this: is your change history thrown away or preserved? Everything in recovery flows from that one answer. Here are the practical consequences. And this is exactly what interviewers want to hear, because it shows you understand why the switch matters, not just what it is. Only in archive log mode can you do 3 critical things. 1. Online or hot backups. You back up the database while it stays open and serving users, so 0 downtime. 2. Point-in-time recovery. You can rewind the database to a specific moment, say, the instant just before someone ran a catastrophic delete. 3. No data loss after a media failure. If a disk dies, you can recover it without losing committed transactions. The cost of all this is disk space and the management of those archived logs. But for any production database that actually matters, the answer is always the same. We run in archive log mode. Say that with conviction. Let's trace the flow in archive log mode so it's concrete. A redo group fills as LGWR writes to it. Oracle performs a log switch and moves on to the next group. Then RCN steps in and copies that filled group to the archive location, the FRA usually. And only after that archive copy is safely made is the original group marked safe to reuse. The history is preserved before anything gets overwritten. Now picture no archive log mode. It's the exact same flow, except the archive step is simply skipped. The group gets reused the moment it's no longer needed for crash recovery, and its history is gone. That single missing step, the ARCHIN copy, is the entire difference between a database you can truly recover and one you can only restore to last night's cold backup. So how do you actually turn it on? 4 steps, and one of them is a beautiful callback. You shut the database down cleanly with shutdown immediate. You start it in mount, not fully open, just mount. You run alter database archive log, and then you open it with alter database open. The key detail, and it's a favorite in interviews, is that the switch has to happen in the mount stage. Why? Because from Chapter 5, mount is where the control files are read, but the database isn't open to users, which is exactly the right moment to change something this fundamental. Volunteering that you do it in mount tells an interviewer you genuinely understand the startup sequence and how these chapters connect. It's a small thing that lands big. Let's verify it live. The quickest check is archive log list, a SQL plus command that tells you the database log mode. Here it says archive mode, plus whether automatic archival is enabled and where archives go. You can also confirm straight from the data dictionary by querying log mode from $database, which returns archive log. To see the archiving history and the actual archive logs, you've got $log history and $archived log. And the fast recovery area usage, how full your archive destination is getting, which you do need to watch, shows up in $recovery file dest. So one command to check the mode, a couple more to see the history, and keep an eye on space. These all show up again in Chapter 17. Let's lock it in. Rito records how to reapply changes, and LGWR writes it at commit. That's durability. Checkpoints bound recovery, so it starts from the last checkpoint rather than the beginning of time. The big switch. In NOARCHIVELOG, filled redo logs are overwritten and lost. In ARCHIVELOG, Archon archives them first, preserving a complete history. That history is what enables hot backups, point-in-time recovery, and surviving a media failure with no data loss. And 2 details that impress. You flip archive log mode in the mount stage, and production always runs in archive log. That closes out Phase 2, storage. Next, we open Phase 3, access. Who's actually allowed to use this database? We start with users, privileges, and roles. That's Chapter 11.